Hello again. This is Math 1102 coming to you from the College of DuPage. This lecture is for 4-10-24 and covers material through 7.5. You're to read examples from the text and attempt the problems here before viewing the solutions, which are also shown here using buttons such as this. We're going to cover several topics, including these. One thing that should be mentioned is that instead of using all the techniques, the nursing faculty at the College of DuPage recommends you use dimensional analysis wherever possible. The only exception to that is when we start talking about calculating the amount of a concentrated solution and a dilute needed for a desired strength, we'll use inverse proportional equations. As you know, nurses administer medication orally, abbreviated PO, intramuscularly through a shot, IM, subcutaneously, that is holding it under the tongue, or through IV fluids from a prepared solution, and that's a stock solution. The strength of solution is stated on the label. And so solution strengths are usually labeled in one of the following ways. 25 milligrams per milliliter. If you have a ratio like this, it tells you the amount of medication in each milliliter of the solution. Sometimes it's shown as a ratio, 1:4. Ratios written in this way always mean grams per milliliter. This solution contains 1 gram of medication in every 4 milliliters of solution. 30%. Percentages describe the amount of medication in grams in every 100 milliliters of solution. This solution contains 30 grams of medication in every 100 milliliters. Sometimes it is shown as 40 grams equal to cc, cc standing for cubic centimeters. This equation tells the amount of medication in the given volume, and that is 2 cubic centimeters. Sometimes it is shown as specific units. U100, certain solutions list units per milliliter. This solution contains 100 units per milliliter. More about this later. And 20 milliequivalents per milliliter. This ratio tells the number of milliequivalents per milliliter of solution. Again, more about this later. For now, you should read section 7.1 and have attempted problems 1 through 17 as the syllabus directs. Now, in 7.2, there are 4 acceptable ways that they talk about of calculating solution dosages, but the nursing faculty at the College of DuPage wants to use dimensional analysis whenever possible, and so that's what we're going to do as we work through some examples. You do not have to know all of these techniques, only dimensional analysis. So suppose the doctor ordered 15 milligrams intramuscularly, and this is every morning. The label information is 20 milligrams per milliliter. So what's the patient dosage? Pause and give it a try. Let's see how you did. Okay, so you see, we want to know how many milliliters to give. So using dimensional analysis, we're going to take 15 milligrams times 1 milliliter per 20 milligrams. And whenever we do that ratio calculations, the milligrams cancel and get 0.75 milliliters. In this example, the doctor orders 25 milligrams a shot twice a day. The label information is 1:4 strength of a solution. What's the patient dosage? Again, you're trying to say how many milliliters do you use? Give it a try. Let's see how you did. So using dimensional analysis, we want to have an answer in milliliters, so it's 25 milligrams. Sometimes it's useful for students to put that over 1. And this is 4 milliliters per 1 gram. And we have to change the milligrams to grams. or the grams to milliliters actually, and so we have to multiply by a conversion factor of 1 gram per 1,000 milliliters. The milligrams cancel, and the grams cancel, and we have 0.1 milliliters. Here's another example. The orders are 50 milligrams by mouth, and this is every evening. And the label tells us that it's 25 milligrams of medication per 2 milliliters. So what is the patient dosage? Please give this a try. Let's see how you did. So we want to have milliliters, so this is going to be 50 milligrams over 1 times 2 milliliters per 25 milligrams. The milligrams cancel, and you will get 4 milliliters for your answer. Now, sometimes units for insulin, heparin, and some penicillin, and this is a hormone, are manufactured in units rather than milligrams. These medications are listed as having a stated number of USP units. This designation refers to the fact that the composition of the unit conforms to specifications laid down by the United States Pharmacopoeia, which is the official drug publication of the United States government. The doctor will usually prescribe the dosage in units, and here U100 is a standard form for insulin, meaning 100 units per milliliter. Previously there were other versions, but now those have been phased out, and this is what is used today. And you should note that U100 has 100 milliliters per unit. So in this example, you were to give 30 units of U100, and so what you do, if you have an insulin syringe, you move it up to 30 units. And if you're told to use 30 units from a syringe that is graduated into milliliters, you're going to say that U100 is 100 milliliters per unit. So the question is, how many milliliters of insulin are needed to give 150 units of U100? Give this a try. Let's see how you did. Here we're using dimensional analysis, so we take 150 units over 1 times 1 milliliter per 100 units, because that's what this dosage is, and the units will cancel, and you get 1.5 milliliters. Here's another example. How many milliliters of insulin are needed to give 80 units of U100? Again, you should give this a try. Let's see how you did. So you take milliliters here, that's the unit you want. We're doing dimensional analysis. You're giving 80 units, and since this is U100, it's 1 milliliter per 100 units. The units cancel, and we will get 0.8 milliliters as our answer. The next example, how many milliliters of insulin are needed to give 60 units of U100? Again, pause the video, give it a try. Let's see how you did. So again, dimensional analysis, you take this is going to be 60 units times 1 milliliter per 100 units. I could have put this over 1 if I wanted to. So the answer, the units cancel, and you will get 0.6 milliliters. Milliequivalents. Some medications are measured in amounts called milliequivalents, and that's abbreviated this way, M, capital EQ. When milliequivalent units are added to an IV, they're usually added to 1 liter, 100 milliliters of IV fluid. Milliequivalent weights is 1/1000th of an equivalent weight. Milliequivalent is used so the relatively small quantities found in medication can be expressed in whole numbers. The term 154 milliequivalents of sodium per liter, and that would be written 1.154, not 1.54, 154 milliequivalents per liter, means that there are 154 thousandths of an equivalent weight of sodium in 1 liter of normal saline solution. So to find the milliequivalent volume to give patients, either added to the fluid or given orally, you use dimensional analysis in this class. So if we had 6 milliequivalents of medication in 1,000 milliliters IV fluid, and the medication label told us 1.5 milliequivalents per milliliter, how many milliliters will you add to the IV fluid? Give this a try yourself. Let's see how you did. And so we take 6 milliequivalents and we multiply by 1 milliliter per 1.5 milliequivalents. That was the medication. Label the milliequivalents, cancel, and you get 4 milliliters. Here's another problem. Suppose it was ordered 3 milliequivalents of a medication and you had available 1.5 milliequivalents per milliliter. How many milliliters would you administer? Again, give this a go yourself. Let's see how you did. Again, using dimensional analysis, we want to have milliliters, so this is going to be 3 milliequivalents over 1 times 1 milliliter over 1.5 milliequivalents, and that's going to net out to be 2 milliliters. Another example, suppose it is ordered 80 milliequivalents orally every 6 hours. The label information was 20 milliequivalents is equal to 5 milliliters. How many milliliters do you give per dose? Please pause the video and give it a try. Let's see how you did. And so you will have number of milliliters. It's 80 milliequivalents over 1 times 5 milliliters over 20 milliequivalents. We want the milliequivalents to cancel, and we get 20 milliliters as our answer. Suppose you're ordered 8.5 milliequivalents of magnesium sulfate, and the label tells you that magnesium sulfate has 81.2 milliequivalents per 100 milliliters. How many milliliters do you give? Please pause the video and give this a try. Let's see how you did. So this is the number of milliliters, so you take 8.5 milliequivalents over 1. This is 100 milliliters over 81.2 milliequivalents. You do the calculation and you get 10.5 milliliters as your solution. Now, sometimes you will have elderly patients and there will be lower dosages that are frequently there due to their advanced age, decreased metabolism, other medications they're taking, multiple diagnosis, multiple illnesses, poor nutritional status, and deteriorating mental condition. Okay, because of these problems, the normal dosage may need to be altered, and a doctor will do this. These are the problems that you should do in this section as recommended by the syllabus. Now we move on to dosage calculations for medication in powdered form. Many medications, such as antibiotics, are unstable when stored in a solution, and therefore they're packed in a powder or granular form in a vial. These medications must be dissolved before using them by adding a sterile liquid to form a solution that will increase the volume. For example, if you need a total of 10 milliliters, you may only add 8.5 milliliters to form the final volume of 10 milliliters. The powder takes up the remaining volume. So read the information packed with the medication regarding the amount of a diluent to be supplied and the type. The label on the medication will tell you how much sterile liquid to add and the final volume to have in the vial. If more than one dose is given from a vial, and sometimes it's not, write the date and time of the preparation directly on the vial, your initials, and the strength of the solution if it is not already indicated on the label. And you will be told to do these problems the doctor's ordered, the charted amount, and the label information to solve problems. And when you do that, you will need to calculate how much to give per dose and this will be in milliliters or cc because you're administering fluid, how often to give it, and how to relabel the vial if it is multi-dose. These will be the things that I will be testing you on. When calculating how much to give, use one of the dosage calculation formulas. We will tend to use dimensional analysis. And many hospitals will require the nurse to put the patient's name on the dose vial along with the dosage and the time of preparation. And here in this text, we don't require all of that, but be aware of your local conditions. Okay, so let's do some examples. Suppose you were ordered 75 milligrams to be given by a shot every day at 10 a.m. And the label information is 1 gram of medication. And it says inject 1.5 sterile water to yield 2 milliliters of solution. And they note that this will only be stable for 6 hours. And since you do this daily, you're going to discard the vial, but we'll get to that later. So how much you should give and how often. Please give this a try. Let's see how you did. Okay, so let's do dimensional analysis. So the number of milliliters is going to be 750 milligrams times, and the medication is 2 milliliters of solution per 1 gram. And you do have to change the grams to milligrams, and so you cancel these, you get 1.5 milliliters. You do this every day at 10 a.m. and you have to discard the vial after you've added the 1.5 sterile water to the solution. So you discard the vial in this case because there is not going to be enough to give another dose. Let's do another example. Suppose you were ordered 250 milligrams to be administered via a shot 3 times daily, and the label information is 1 gram of medication, and you're to introduce 1.7 milliliters sterile water to yield 2 milliliters of solution. You have to keep this refrigerated, and this is stable for 3 days. So how much do you give and how often? Please give this a go yourself. Let's see how you did. So we're using dimensional analysis of 250 milligrams over 1 times 2 milliliters per 1 gram. And you have to change the grams to milligrams in order to have the units be just milliliters. And this is an IM injection. You do it 3 times a day, and you should initial this because you will have more dosage that you can do. And you keep this refrigerated, and this is stable for 3 days. There's another thing where you will have a number of vials that are in your storage cabinet, and you get to choose which one you use. So occasionally the label may specify the amount of sterile liquid to be added for various strengths of medication. In order to control the total volume of the solution that results when you reconstitute it this way, the manufacturer provides specific doses and specific amounts of solution. In this situation, the easiest arithmetic implies that you should choose the dose closest to, but not exceeding, the ordered amount of medication, and then calculate the dosage using medication strength. If you're giving this intramuscularly, that is, you're giving a shot, the least painful is to the patient is to use the least amount. However, to avoid too heavy a concentration, try to use a strength that will allow you to administer between 1 and 2 milliliters. This is usually the strength closest to, but not exceeding, the ordered amount. And here is an example where there were 750,000 units of penicillin ordered, and you have some choices here. And that's the amount of diluent that you put when you do this. So how much do you give the patient? So here you choose to add 8.2 milliliters to make a solution of strength 500 units in 1 milliliter. This is the strength you would administer, and the amount that you will do is between 1 and 2 milliliters. In fact, you're going to do 1.5 of that, and that tells you how much of a diluent to use. Let's do some problems with this. So suppose you're to give 100,000 units every morning, and these are your choices. How much of what strength do you give the patient, and how often? Please give this a go. Let's see how you did. Okay, so you are going to choose to give the 100,000 units per milliliter. And so what you're going to do is you'll use dimensional analysis. You're administering 100,000, that's every morning. This is the ratio. It is 1 milliliter per 100,000, and so you give 1 milliliter of this. And since you are going to have more of this than 1 milliliter, you will note the time and put your initials on the label. Here's another example. Suppose you're ordered 75,000 units every morning. These are your choices. What strength should you give and how often? You're going to be giving it every morning. Give this a go, please. Let's see how you did. Okay, and so what you do is you're giving it in the morning. You should date and time because there's some left over, but the number of milliliters you give is going to be what was ordered. And this is the conversion factor for that one that you're using. And so you give 1.5 milliliters. And again, there's some left over for another dose, so you date, time, and initial the label. And you should, as the syllabus recommends, do problems 1 through 20 in 7.3. Sometimes you are calculating the amount of medication in a solution. To determine the amount of pure medication by weight in a solution with a specified strength, you will use dimensional analysis. And so the strength of pure medication is 100%, and the strengths are stated as a percentage or a ratio. And when you use a ratio, that always refers to grams per millimeter. So there is an example given in your book how much bicarbonate, sodium bicarbonate is contained in 500 milliliters of a 5% solution. Give this a go. Let's see how you did. And so you're using dimensional analysis, so the number of grams is going to be 500 milligrams, and this was the strength of the solution, 5 grams per this. And so your milliliters will cancel, and you're giving 25 grams of medication. And here, as in the syllabus, are the problems that you should do from the textbook. Finally, we're going to diluting solutions, and this is different in that there is an inverse proportionality that is involved. And so what you have is the smaller percent divided by the larger percent is a smaller volume divided by the larger volume. Okay, and so you see that that's the ratio that you have. Another way to look at this is sometimes called the dosage formula. And so what we're going to have then is the available volume times the label strength is the dosage volume times the desired strength. It's best if we look at these as a few examples. So the first example we look at is how many milliliters of a 20% solution are needed to prepare 50 milliliters of a 5% solution. Please give this a go. Let's see how you did. Again, this is an inverse proportion. So 20% over 5% is 50 over X. So you want to determine the milliliters of a 20% solution. So what we will do is this is 4 over 1 is 50 over X. We cross multiply, getting 4X is 50. So X is 50 over 4, or 12.5 milliliters. So this is 12.5 milliliters of the 20% solution, and you have to add 3.75 milliliters of diluent. Both of these are parts of the answer. The next example, how many milliliters of a 1 to 10,000 solution are needed to prepare 500 milliliters of a 1 to 20,000 solution? Please give this a go. Let's see how you did. Okay, so it's going to be X over 500 milliliters is the ratio of this to this. Now this ratio can be reduced to 1/2, and so you have 1/2 is equal to X over 500. So we cross multiply. 2X is equal to 500, X is equal to 250 milliliters. So you take 250 milliliters of the 1 in 20,000 solution and add 250 milliliters of diluent because you want to have a total of 500. And you should do, as the syllabus suggests, problems 1 through 19 in your textbook. In closing, I'll look forward to seeing you next Monday. You have plenty to do, and we'll be moving on to Chapter 7.6 in your text. Please take care, and God bless you all.